Hi, so this is going to be the second video of mine on vectors. This will be on vector addition. Right, so there's essentially two strategies for vector addition. They're quite similar when you think about it, but I'll just start by describing the first. So the triangle law of vector addition. So what that means is you can have two vectors arranged like this. So we'll say that this is vector A, this is vector B. Right, so if you want to add vector A plus vector B, then we're going to have to go from here to here. That's right, so this will be vector C. So vector addition is essentially just going from the beginning of the path that you would have taken. So let's say we're walking along these vectors. We could go along A and then up to the end of B. That would be the same as traveling just along C. And that's vector addition essentially. So if we go like this, we can see that vector A plus vector B is equal to vector C. Alright, now we can have things like vector A plus negative vector A, and that gives us what we call the zero vector. Now, the zero vector isn't the same as the number 0. It's not equal to 0, because any addition of vectors can't give you a scalar. It has to give you another vector, a scalar being a simple magnitude. Right, so the other way of doing vector addition is what we call parallelogram law. So that can be used when you've got two vectors tail to tail like this. And all that means is that vector A plus vector B is equal to vector C, look about like that. So all you have to do for that is make a sort of path to make a parallelogram, and this should have the same magnitude as B, and this the same as A. And this in the middle here will be vector C. Right, so once again you can say that vector A plus vector B equals vector C. Now that's essentially the same as the triangle law. All you've really done is you arranged it so that B is over here now, and done it the exact same way. You're still getting the same sort of, I walked this way this far, and then I walked this way this far. And you're getting the same sort of idea where you only had to go along the vector C to get to the same point. Alright, so you can do more complex things. So say we have a shape that goes this way. So this is vector A. We got vector B, vector C, and we'll toss in one more, vector D. Right, so vector A plus vector B plus vector C plus vector D is going to be equal to this right here, which we can call vector Z. Right. So once again, same idea. You just sort of walk along the path of A, then on B, then all the way down C, and up D, and you'll get the same places you would have gotten if you just walked from the tail of A all the way up to the head of Z. Right. So that is essentially it for vector addition until we get to actually using numbers and directions for it. And that'll be the end of this video. So thank you for watching. Bye-bye.